So now we're going to talk about construction of images in a concave lens by ray diagrams. That means we're going to learn how to draw a ray diagram in the case of a concave lens. So here you can look at the diagram which is given here, and the criteria is that this diagram is used only when the object is at infinity and the rays coming from infinity are parallel. So in the case of convex lens, unlike concave lens, the rays diverge instead of converging like concave lens. So how do you find the image formation? At which point the image is formed? First, you have to draw the refracted rays. And of course, O is not deviated because any ray traveling through the optical center does not suffer any deviation. Now, by placing a scale, you draw a line backwards, but not a perfect line. A dotted lines is preferable because it is just an imaginary line. In physics, when you draw a complete line, it shows that it shows a ray of light. But since this is an imaginary line, you make sure that it is dotted. So you have to draw the dotted lines from the refracted rays for all the rays coming from the concave lens, and the point at which they meet is the place where the image will be formed. This is in the case of convex lens, when the object is at infinity and the rays coming from it are parallel. Here you can see the image is being formed at f1 and the optical center is here, hence it suffers no deviation over here. For the concave lens, when the object is placed at infinity and the rays coming from it are parallel, then the image is always virtual. It is always virtual, erect. That means it is not upside down. The image is diminished to a point. That means it is so small that you can barely see it, and the image is formed at f1 on the same side of the object. That means the image is formed exactly at the first principal focus. Uses of this lens is used as a Galilean telescope. That is, it will not be used as the magnifying glass, however, the eyepiece. This will act as the eyepiece from which you will see through the telescope. The topic is how to draw a ray diagram when the object is placed anywhere between the optical center, that is O, the optical center, and infinity, that is from here to anywhere in this line. So how do you draw this? So by looking at this diagram, you can tell that it is a concave lens, and you draw this diagram by first drawing a parallel line or a parallel ray passing through a parallel ray to a ray of light parallel to the principal axis, which suffers deviation due to refraction. And how do you draw this deviation? By holding a scale at f1, the first principal focus, and then you draw dotted lines from here till the lens, and then you draw the straight line. That is how you draw the refracted rays. And for the second incident ray, since it passes through the optical center, it suffers no deviation and it goes in a straight line, as you can see in the diagram. So F1 here stands for the first, the first principal focus. F2 stands for second principal focus. O stands for optical center, and AB is the object. And here at A1 is the point where the image will be formed. Usually, when in ray diagrams, the refracted ray or the reflected rays are considered for image formation, but in this case, the first ray, since it does not meet, since they're all diverging rays, the imaginary line which passes through the first principal focus and the second incident ray which passes through the optical center, and the point at which these two meet will be the place where the image will be formed, that is A1. In the case of this, the image is always virtual, the image is always erect, the image is diminished, as in that means that the image is still small, and the image is formed between the optical center and the first principal focus F1 on the same side as the object. That means it is a virtual image. Any image which is formed on the same side as the object is considered as a virtual image. Any image that is formed on the right side of the object or the opposite side of the object, then it is considered as a real image. Here, as you can see, the image is formed anywhere between the first principal focus F1 and the optical center O. So this lens is used, this convex lens is also used for correcting short-sightedness in the human eye. That means it is used in spectacles by opticians.